My name is Dennis, and for the next 20 minutes, I'd like to talk to you about learnings. So, learnings usually involve failure, so I'm going to talk about failure as well. But before I start, I would like to know one thing. Who of you in the audience has to wrangle with data on a daily basis? Like really working with data? Okay, I'd say about maybe half, a bit more than half. Thank you. And who of you in the audience is responsible for business value of data science, like making money out of it? Okay, maybe 10%. Thank you very much. Okay, before we start with the learnings and the failure, why am I standing here in front of you? So my name is Dennis. I'm the CTO of a software company called GPredictive. What we did in the last 5 years is we developed a statistics software as a service solution that only fulfills one purpose. And this purpose is to enable people who are not data scientists to build predictive models that allow them to optimize the decisions in the customer journey of their customers. That means that they can make decisions of the type like, do I send this person now a coupon mailing, or do I send this person maybe a voucher for something? So in these decisions, they have to be made like constantly, and a lot of them. So our software offers the possibility to let the predictive models do the decisioning for our clients. And we work primarily in the retail and e-commerce space. I'm going to tell you in a minute why this is focused that way. Okay, so I told you what we built. And the key mission that we wanted to fulfill was we wanted to automate predictive model building for everyone, not just statistic nerds like us. So that was our goal. And we came from the consulting industry, so we did this for clients and their software stacks for years. And then we thought, okay, there must be a simpler way, a better way, because we were repeating ourselves all over again all the time. And when we talked to our friends and colleagues from our industry, they were like basically laughing at us and telling us that, come on, that's just plain impossible to do that. It's too many things you would have to account for. It would just never work. So that motivated us a lot to really try it. And when we tried, yeah, we failed at almost everything we did. And thus, we did learn a lot. And today, I'm going to share with you the 5 top learnings from the last 5 years. And I hope I have some advice in there that may help everybody who's going to build a predictive platform or who wants to automate data science. Learning number 1. Choose your domain and really, really own it. What does that mean? It means that when you solve problems you can solve with machine learning, you basically have no free lunch. That means you cannot just beforehand choose any kind of approach, business case, or algorithm that works best. So the theory says if your problem set is large enough, all algorithms you're going to use on that problem set will perform equal. There's no champion. So you cannot just say, okay, I have this algorithm and I can solve every problem with it. And we found out the hard way that this also applies to business domains. So what we learned here, really, really, really hard, was that you have to double down on a certain niche you're going to cover. You have to understand the business, you have to understand the domain specifics, you have to understand the domain-specific data, and if you are no expert in that domain, you might even have to hire an expert of that domain. Otherwise, you will have never lunch, neither paid nor free. And I'm going to share the story of our product offering. So when we started out in 2012, we were like this guy on the right. We were just thinking, okay, come on, we're really good at doing this predictive thing. So, I mean, it's all zeros and ones in the end. So every problem a customer can come up with, we will solve it. So we offered predictive pricing algorithms, we offered predictive inventory management, predictive lead scoring, and everything customer intelligence you could imagine under the sun. Fast forward 1 year, our motto changed from you name it, we have it, to, well, we can't just do everything, right? So we ditched predictive pricing. I mean, kudos to all the guys out there who do predictive pricing. It's really hard. And we found out that the predictive pricing people have completely different mindsets from the predictive inventory management people. They need completely different metrics. They want completely different results. So we thought, now, OK, we are in a better space now. 1 year later, we ditched predictive inventory management. That didn't work too well, so we said, OK, now we have a niche. We're going to do CRM, but we're going to do this really fine and really nice. So yeah, 1 year later, we ditched predictive lead scoring. So we just said, OK, it's a large business space, a lot of competitors in that area. So we're really going to narrowly focus on customer intelligence. That means our models optimize the behavior towards people that are already customers, to nurture them, to retain them, to make them spend more money, basically. So, I mean, that's it, isn't it? Now we have it, almost. This year, we said, OK, yeah, customer intelligence is really nice, but then you have all these problems with like contractual obligations. You know, when you're at an insurance or a bank, you have these complicated data, and we said, OK, now we really have it. We are the retail experts. That was almost it, because then we found out, OK, when you're a really small company working in retail or e-commerce, you have really 99 problems, but data science isn't one. You have to solve other problems before. So this is our first final focus. We do predictive customer intelligence, but only for retail or e-tail merchants with 20 million euros of annual revenue. And I'm guaranteeing you, if I were to hold this presentation in another year, there would be another but on that slide. So that was really hard learning, and we almost killed the company several times in that process. This one is really fun. It's a technical one, and I think it's the second most important thing. You have to be obsessed. You have to be obsessed about the data you're going to get. Because when you're building a platform, you're going to have users, you're going to have clients. And these users may have a different mental model of what good data represents than what your software does, or what you have. So once you have really nailed your niche, and you know what you're going to offer, you really need to lay out an exact plan what your software allows in terms of data, and you have to stick to it. If it's possible in your domain, you should really try to design a fixed data scheme that's completely constant, that still allows for a little bit of flexibility. In our domain, it was possible. I'm happy to share it afterwards. It's quite a nice exercise to do that. And then the most important point, and we only learned this recently, you have to programmatically, that means automatically, reject every data set that does not 100% comply with your scheme. There is no bargaining. Because if you let this go, and we let this happen, you're going to have a lot of conversations that look like this. You know? And I'm talking again about mental models. We said to the client, OK, you can give us the data, but please specify the encoding of the data you're going to give us. Because everybody in the room who wrangles data knows encodings are really hard to guess, and they screw up everything if you don't get them right. So the client uploaded the data into the software, and it was a completely garbled, weird-shaped Excel file. And we were like basically calling that person and said, what the... And he said, no, it's fine. I mean, the encoding is XLSX. So, you know, that's not to mock the clients. It's basically just saying you have mental models. You have your own mental models, how it should be, and the clients have their mental models, how it is. And some people think the file format is the encoding. It's OK, it's fine. But you have to talk about this beforehand. Learning number 3. That was the one that struck me most, because I come from a data science background. I'm not a developer, so I worked in pure data wrangling, and I come from academia, so I was not really about productionizing things, automating and testing everything. Because when you do data science, and the people who do it on a daily basis will know it, it's not for the faint at heart. You have to do millions of little tasks. You have to ingest data, you have to prepare it, you have to look at the models very carefully, and then you have to score it with different data, and then you have to evaluate it. And all these tasks, they're all critical. So if you just screw up in one of it, you will have exactly the opposite of what you wanted. Everything will be wrong, basically. And oh yeah, we've been there. I mean, before we had everything completely automated, basically everything we shipped was wrong, and I'm still convinced that 70% of the projects in data science in our industry fail because they just deliver the wrong results. And with wrong, I mean the score is not sorted descending, but ascending, and all this. And what we had to do, we had to ditch the data wrangling mindset in our company. We had to think like developers, like software engineers. And at the end, we arrived at a state where every feature, even adding a new column to a table, is test-driven. And we have a test suite that completely tests everything, from uploading the data to evaluating the finished scores every night and at every deploy, which, of course, is also automated. There are no process handbooks. There's no process. There are no PowerPoint slides. The process is in the software. And the last one is my favorite. Everybody who works with data knows you have these one person, and she's like the hero that saves the day when you're approaching a deadline and the client of your software did something wrong, and then she types and codes and wrangles all night. And 1 minute before the deadline, everything is fine, and you deliver the model, everybody's happy. And yeah, we did this, and every single time we did this, it came back to bite us. Because the code wasn't committed, it wasn't checked in, it wasn't tested. So 3 weeks later, when we wanted to update that model, everything went to shit, basically. So in our company, this mentality is now frowned upon. We are like boring people. We want that every day is the same, you know? Everything is tested, everything is taken care of. Okay, learning number 4. This is going to resonate a lot with the data scientists as well, because I'm saying that, you know, algorithms, they are not that important. I mean, this is a bold statement, and let me put some relative value on that. Not that important for our platform. So you see this curve. It's for all the people who don't do data science. It's called area under the curve, and it basically tells you how good your model is. So the more space you have between the colored curves and the diagonal line, the better your model is. And when we started out, we had this really nice ensemble method. We had like every algorithm under the sun, gradient boosting, logistic regression, random forest, support vector machines, and all that. And during these 5 years, we estimated about 10,000 models with our software, and 95% of them looked like this. You see, you can't even tell the curves apart. They are all the same. And the really crazy ones, like the 5% that were really different, they look like this. And everybody who productionized data science knows that this also is the same. Maybe not the logistic regression, it's a bit worse, but the rest is, in production, it's all the same. So what we did is, we did bootstrapped reruns. That means we took 90% of the data, applied all algorithms on it, and then we took another subset of 90% of the data and also applied all algorithms to it. And we found out that the difference between the same algorithm with a different bootstrap is larger than the difference between algorithms in one bootstrap. So by just repeating an experiment with resampling, you have a larger difference you have than when you just employ different algorithms. So in our special case, we just ditched ensembles. And I mean, I'm looking at you, gradient boosting. We now have 95% reduced resources for doing the modeling. And we deliver pure stock random forest as they are implemented in scikit-learn today. There is a cautionary warning. It's not the freelance theorem contradicted. I'm not telling you the random forest is the best all-end-all algorithm. We only found this out for our niche, for our domain, after running like thousands of models and carefully analyzing this experiment. Okay, learning number 5. This is the thing that was personally for me, I think, one of the hardest things to learn, because as I said, I'm more like a data science guy. I like to sit in the dark and do analysis. And sometimes you need to have clients, and clients They say runtime doesn't matter. So, basically, as a data scientist, you want the best possible result, even if it takes you months. But people are impatient. So why is that? If you have to really ship things, if you have to deliver data science that actually generates money, you have to have iterations. The first iteration is always going to be bad. The second also. So you need to have time to make your iterations before the deadline hits you. So you need to be able to fail fast, because if you fail and you have 5 minutes until the deadline, it's not really funny. And the third point is, and it's actually the only UX topic I'm going to talk about here, because UX would be like 10 other presentations. When using software, especially in a browser, people don't like to wait. I saw a presentation today about visualization where the referee said 6 seconds is an eternity in the internet, and she's right. So speed is a genuine feature. And this is our learning scale with respect to speed. When we started, we basically had glued together some R scripts with some SQL at the edges to handle the data. And we said to our clients, come on, just give us your data. We wrangle as long with it until we have a result. And it's only going to take 4 weeks. Awesome. Great. And the first automated version of our software in 2015 took a week. There was a data preparation process, basically an SQL script, that ran 5 days because our client had 1 billion rows and it didn't scale. And it failed on a Saturday, of course. So we changed that. And thanks to Apache Spark and horizontal scaling, for the same data, we now need between an hour or 8 hours, depending on the complexity of the data preparation. And we have a vision, and I mean, that's a bold thing, but we ran tests on it, and it's possible. We want that each step of the data science process completes in the time that is normally the maximum timeout time for a request on the web, so in less than 60 seconds. So you have your data preparation in less than a minute, you have your model in less than a minute, you score in less than a minute, and your evaluation in less than a minute. Total runtime of everything, under 10 minutes. So you can build 10, 20, 30 models a day if you want. That's our vision. And I'm coming to my conclusion. It's these 5 things that I think are the most important things to take care of when you build a self-service data science platform. Thank you very much.
Thank you.